Woo.
We're live.
Good morning.
Morning, everybody. First things first, Mrs. Smith, I don't think we need to write people's names down today because we have a better way to do it today. But it would be nice to know who's here. So in the chat, if you could just say hi real quick. You know? So this is a YouTube live stream for you misplaced Twitchers out there. You know. Just saying. So real quick, hi, who's here? See Deanna, see Nolan.
Nick, I don't know who Suna is.
Hannah Reed.
Maddie's here. Did I say Nick?
The Moth King is here. The Moth King. Rosa is here. I see Rosa up there. I had to scroll back up here.
Keish is here.
Brian is here. Keish is here. Keish. Miss Keish. She left me. I don't see her every day anymore.
I know. I have to figure out how to do a VIP squared meeting with her. Not in person.
Who else?
Tyler C. Tyler C? Do you have a Tyler?
Yep. Where did you see Tyler?
Elijah's here.
I don't see Tyler.
It says, I'm Tyler C. I don't know who Tyler is.
Oh. Okay, got it. Let's see. No, Daniel. See Daniel's here.
Anthony's here.
I see 11 people watching right now.
Creepers.
Ooh. Elijah's here. It's acting funny again. That's not a good. What's acting funny again? They were talking about Blend not working real well earlier.
Oh yeah, I've heard that today. But luckily, all of your work for us is on Moodle.
Yeah, you don't have to worry about it.
No
so
problem.
if you can't do work for other teachers, just do your biology. Right? I mean, it's the only important one anyway. Lamaya in the house. I think we said hello to Rosa. All right, let's get going. We got 12 people, 13 people here. Listen, like I said, we're not writing down names for attendance and bonus points right now because we have a better way to do it today. But you have to stick around for the end for that. So the first thing that we would like to do is talk a little bit about the Bioenergetics Handout. I know a lot of you have done that. I know a lot of you are getting to that point. I think if you pay attention, it will make that paper pretty easy. Once we get through that, we will jump into the other thing, the whole. You know, we're still thinking bonus points, aren't we, Mrs. Smith? We want to reward you for coming. Although, like in a perfect world, you'd all be here because you want to learn. But you know, whatever. All right, so I got to pull my screen up, and I have to look at another monitor. So I'm gonna do a full screen here. Well, maybe not, because you still could see Mrs. Smith's bright smiling face. So I have the Bioenergetics handout up. I have it in. Well, is there anything that you wanted to add before we moved on, Mrs. Smith? Sorry.
No. You're
Good.
okay.
Good. I have the Bioenergetics handout up here. I'm going to go over this first diagram, and that's going to let you understand the second diagram. Like, I don't need to go over it because it's going to be easy once you understand this. Now, I have opened this in DocHub. And for those of you that are just going remote or have been remote or whatever, DocHub seems to be the way for students to do things online. Like, if you want to do some of these documents online, it really seems to work well. Anyway. You know what? I moved it over to the other screen, but the other screen isn't touch screen, so this could be hard. Anyway, we'll go with it. So this is photosynthesis. All right. And it asks you to label some things. H2O, CO2, C6H12O6, which you immediately are thinking glucose, oxygen, the thylakoid, the stroma, the light-dependent reaction, and the Calvin cycle. So I'm going to kind of do that really, really quick. And then I want to talk more about the diagram than the labels. So let's see if I can do this with a mouse. This top box, what do we have coming in? We have H2O coming in. Oh my gosh, writing with a mouse is always fun. H2O. It makes you look like a child. That's coming in, and these green discs here, hopefully you know what those are by now. Let's label that too. That's the thylakoid. What if I just label it with a T for thylakoid? So the H2O is coming into the thylakoid. That is going to be the light-dependent reaction. Guys, one of the beautiful things about science when you see it is you don't have to memorize it if you understand it. How do I know this one's the light-dependent reaction and not the Calvin cycle? Because there's light coming into it. See what I mean? All right. So then coming out of that is O2. And if we think about the equation for photosynthesis, we know we start with H2O and we end up with O2 on the other side. Now let's pop over to this side of it. We have CO2 coming in. And like I said, we're trying to label it kind of quick. CO2 coming in. That's coming into the Calvin cycle. And we're losing, or we're getting rid of, or we're making the product, that's a better way to say it before Mrs. Smith has a heart attack, C6H12O. Oh my gosh. See, it's not perfect, but you can do it if you can't write it. All right. What am I not labeling? Oh, the Calvin cycle. That's taking place in the stroma. Now, I want you to notice something. Anywhere it's not one of the green thylakoid discs is the stroma. This isn't a big thing. This is just kind of blowing up that liquid. So this would be happening in the liquid right outside the thylakoid. All right, that said, I think we labeled everything, right? Here's what I want you to see. I'm going to change my color here because I can. Look at what's coming in to the thylakoid. We have 4 things coming in. We have light, water, NADP, and ADP. And ADP is what? Adenosine diphosphate. It's 2 phosphates. All right, so you have 4 things going into that. Look what's coming out. You have oxygen coming out. Should I change my color again? I think I should. What do you want? Orange. Your Nighthawks. I have oxygen coming out. I have NADPH coming out. And I have ATP coming out. So I have 4 things going into the light-dependent reaction. I have 3 things coming out. If you go to the other side, it is really the same thing, right? We have 1 thing coming in, 2 things coming in, and 3 things coming in. What happened to my 2? It just takes a while sometimes. And then going out, pink, I guess, pink. We have 1 coming out, 2 coming out, and 3 coming out. So why am I saying this? Because that lines up with that diagram on the next page really well. But what I want to point out is this. If we go back and get a bright color like yellow, yellow's bright. Look at this H with me. A yellow is so bright you can't even see it probably on the screen. Look at this H, follow this H, right? Here's the H, it comes into the light-dependent reaction. We use light, the energy from the sun, to take that H off of water and add it right here in the yellow, of course. Right here in the yellow, there's that H. Let me get another color. I can't do it. How about bright green? Here's this H. Look at it now. It's right here. We also use energy from the sun to take that phosphate, the ADP plus P, put it back on the ADP and get ATP, adenosine triphosphate, 3 phosphates now. Now it's loaded. It's ready to use its usable energy. And we're going to send those 2 things over to the Calvin cycle. We're going to use the energy in ATP to take that H off the NADPH and add it to the CO2 to give us C6H12O6. Once we've done that, the ATP is now ADP again, and the NADPH is now NADP again, and they go back over here to be charged. Where's that H? Look, the H is right here. So this understanding that the H flows from water to NADPH, right? to the glucose. That's all that's really happening here. That's what we're doing. Or not what we're doing. It's what the plant's doing. So it's a cyclical thing, right? We load the NADP and the ADP, and we send it over here. We use it to make sugar. Then it comes back over here, gets loaded in the light-dependent reaction because that's where the energy is. Comes over here to make sugar. That's all this is. And if you scroll down on this page, and look at that. Look, Doc Hub's so nice. It kept the annotations, right? If we scroll down on this page, here it is. Photosynthesis. There's two things. There's the light-dependent reaction. There's the Calvin cycle, light-dependent reaction in the thylakoid of the chloroplast. It uses four things: ATP, NADP, ADP plus P, NADP, H2O, and light to make three: NADPH, ATP, and O2. Right? So once you understand this, filling out that is really easy. All right. So what did I miss, Mrs. Smith, or do you just want to move on?
So all I was going to add is, when we talk about organic molecules and we talk about what it means to be a macromolecule, we talked about one specific element, and that was carbon. That carbon's in every single living thing, whether it's a carbohydrate, whether it's a lipid, whether it is a nucleic acid, whether it is a protein. And so when you're thinking about some of the questions on this sheet, and it's talking about, where is the organic stuff coming from? It's talking about where is the carbon coming from? So if you look at that document, from Mr. Studer filled out in that picture, and we're looking at, glucose is a carbohydrate that's made. Where is that carbon coming from? So if you're stuck on some of those questions, kind of think about that. Where does the carbon come from? Because I'm seeing a lot of soil is what students are telling me. And if we plant a plant in soil, it doesn't eat the soil. Okay. And
right.
Yes, the carbon cycle, or part of the carbon cycle, is dead organisms and plants, but plants aren't sitting there eating the bones of dead organisms. So you're kind of missing steps in there of what happens in carbon fixation and getting carbon back into the air that's then used by said.
I keep thinking, Mrs. Smith, if their theory was correct and you walked out of your front door and walked by a tree, you would fall in a hole. Because if you have a 60-foot tree, it would have had, and it sucked all the soil out, there would be a hole around the tree.
Right. I just picture a big tree with a straw, but
Hey, I'm just going to throw it out. Are we paying attention to this? Guys, that's the point. Don't be a distraction even in Lime Street. Do you have questions in the chat? That's a better thing, because the chat is wonderful. We love the chat, but we like it for people to communicate with us, ask questions, or give answers.
And with everything going in there, if there's a question asked, I missed it.
So, yeah. So let's ask this before we move on. We just talked about respiration. So respiration is the way, if you think about this, we just took light energy. The beautiful thing, the mind-blowing thing about this is we just took energy and transferred it into stored chemical energy. All life on Earth, every single living thing, whether you're talking in the ocean, a lake, a river, a stream, a desert, a tundra, a rainforest, every single thing lives off of this energy that was just produced and stored. So the big question is, how do we then make that energy usable? What's the process that makes that energy usable in the chat? So that's what we're waiting for. Mrs. Smith, while we're waiting for that answer, do you just want me to scroll down to the next page for you to talk about it?
Yeah,
or you
sure,
want
we can go down to that. Yep.
Okay. Or do you want me to share it with you so you can write on it?
Everything that you should be able to do to fill that thing out. And don't forget that question underneath of the flow chart too, by the way, why is photosynthesis important? People keep skipping over that. So that was all photosynthesis. Okay, so photosynthesis takes sunlight and puts it into a form that's storable. Because if you listen to Mr. Studer, we made a little bit of ATP. So why do plants even bother to store it? Why don't they just make it and use it? And one of the reasons is that, I talk to my students about ATP as being really quick, usable energy, and it's gone. You can't send it out everywhere else. And so we need to be able to carry it to other parts of the plant. If this is mostly being done in the leaves, as we've talked about in our live streams before, it needs to be able to go everywhere else. So once we have that stored energy, as heterotrophs, we eat that stored energy in the form of glucose and complex carbohydrates that are made from multiple glucoses, and we still need to then break that down. And so we do that in the process known as cellular respiration. So cellular respiration starts with glucose, and it needs to be broken down in a process known as glycolysis. Glyco, kind of, if you think of glycogen or glucose, and then the lysis portion of that word is breaking apart. So essentially, glycolysis is the process of breaking glucose apart and releasing 2-ATP. So if we're looking at this bioenergetics handout, and Mr. Suter, don't forget, you're kind of in control of writing on that for me. So glucose is going to be broken apart through glycolysis in the cytoplasm and releasing 2-ATP molecules. And so it's also creating more NADPH, which I talk to my students all the time about. I pick things up, I put them down. They're carriers, they're carrying the hydrogens, and that's going all the way over to the last step of cellular respiration. So in the cytoplasm, we have glycolysis, we have the breaking of glucose. And then once that is broken down, those smaller molecules move into the mitochondria if there is oxygen. And that's not on there, but you need to make sure you understand that if there is no oxygen, those broken pieces from glycolysis do not go into the mitochondria. They go into another process that's known as anaerobic respiration or fermentation. And so they ferment and they release either lactic acid or ethyl alcohol, dependent upon the process and the organism that's doing it. So like humans, when we don't have enough oxygen, your muscles get lactic acid on them, which is why you get a cramp. So no oxygen after glycolysis means it goes into fermentation and creates lactic acid or ethyl alcohol. If there is oxygen then after glycolysis, then it heads into the mitochondria and into the Krebs cycle, where we have CO2 being produced as well as a little bit more ATP. Again, also producing more carriers of hydrogen ions that are going to move into that last portion, which is the electron transport chain, where we're going to get that whopping 32 ATP because of ATP synthase that is there in the intermitochondrial membrane. Yeast does fermentation, correct, because it's a prokaryotic cell. And so if it's a prokaryotic cell, Elijah, it doesn't have any mitochondria because prokaryotic cells don't have membrane-bound organelles. So yes, it goes into fermentation. So it does glycolysis because every single prokaryotic or eukaryotic organism does glycolysis. And then after glycolysis, yeast goes into fermentation, ferments, and produces ethyl alcohol, correct? Okay. Did I miss anything, Mr. Suter? I mean, I didn't go. I try not to go too in depth. There's so much stuff we can do with this, but that should be enough to help you complete this chart as well as the flow chart in the next page. And as far as the labeling up above of the mitochondria, we're just looking at the fact that it's a double membrane bound organelle. And so you have the outer membrane, you have the inner membrane, which has a lot of folds in it. And if you look it up, you might see the word cristae for the name of the folds. But I think about this, you know, as far as like form is function. It's folded because that's where you're going to have all of those proteins and the ATP synthases to produce ATP. So the more folds, the more surface area, the more times you can have electron transport chains in that inner mitochondrial membrane, the more ATP you can make. And then the arrow that's pointing to the very center, we call that the matrix of the mitochondria. That's like the center. So you got the matrix, and then the inner membrane that's folded, and then the inner membrane space, and then the outer. So it's a double membrane bound organelle.
These arrows are hard to see, but if you were to, I try to show you on here, but if you're still not sure, just draw them where you know, label them and then draw them yourself a little bit. But those are the things you're trying to label, and those are pretty apparent. So I think you could probably pull that off. My chair's squeaking.
That's okay.
Yeah, I was trying to take care of something there for a second, Mrs. Smith, so I missed some of what you're saying. That's why it was late on the labeling, but
no, that's fine. I think we're ready to go over to our bonus game, though.
I think we are. So here's the deal today. We got 20 people watching. That's good. I'm all right with 20. That's about what it was last week, so it'd be nice to have a few more. But we did promise bonus points. Well, no, we didn't. The bonus points might stop at some, but right now we're still doing it. Here's how we're going to do it. Mrs. Smith and I are both going to assign in bioenergetics a quiz. Sorry. So remember you signed up for quizzes, QUIZIZZ.com earlier this year. If you go into quizzes, you will see a game called Bioenergetics, and you can get in there, and we're going to start that game shortly. I don't have to put up a join code for it because you just need to sign into quizzes. But it's joinmyquiz.com. Go to that. And you should be able to see, once you sign in using your Google thing, you should be able to see. And so here's what we're going to do. There's 20 questions on the quiz. For every one you get right, we're going to give you a half point. That's where we're starting at anyway. For every one you get right, we're giving a half point, which means you can get a total of 10. We might up that. I don't know. It depends. I was hoping there'd be more people here, so maybe we'll up that to make more people jealous. I don't know. But at least right now, bonus, you can get a max of 10 right now. So this time we're making you work just a little bit harder for them. I would like some bonus points. Well, no one who would not like some bonus points. So go to quizzes, joinmyquizzes.com, and I'm waiting for people to join. Are you, Mrs. Smith?
Yep. Hey, Elijah. I double checked because I thought we did this when you came in, but I don't see you in there. So I quick sent you an invite to our class because I know that you weren't on there. So, and you're asking how do I sign in? So go to your email quick, and there's a link in there to sign up for the class, and then it should be there.
All right, McGill's in, Brian's in, so it's working. Whew.
I don't know, but Mr. Fry just sent a update that Firefly should be restored. PS. So you should be good after this too. Darn.
No, there's another update that says it's never going to work, and you should only do biology. If Maya was here, we would call that snarkasm.
Mm-hmm.
Very snarkastic.
Snarkastic.
Rosie, did you click on your sign in, log in, and use your Google? You have to click on sign in with Google. The other Maya's here. I didn't see Maya's name. Maya Plank is here. Annalise is here. Nolan, Lamaya. I'm seeing new names in the game that I didn't see in the chat. Go to quizzes, sign in with Google. Yes. Rosie, you could take it later. Just go to quizzes and sign in with Google. I think you could do it later, right?
Yeah, I'm trying to. It's weird because we have to do it separately. So.
I got 1, 2, 3, 4, 5, 6, 7, 8 in on mine. How many do you have on yours?
1. But I think I might have accidentally put it in incorrectly. Like I signed it as homework, so they might be starting it already. I didn't think about that. So it's kind of in there in both. So if they click their other link. You know what I mean?
Mm.
So like my
student.
student.
Lauren's asking if you should start it whenever they want.
Right. So if you could My students, try and pick the one where I put the word Friday first when you're picking the quiz, if you're still here and checking in that.
All right. So I think while they're getting over, I'm going to start this one. All right, you ready? My students, are you ready?
Yeah, I should be able to see it anyway. So I'm going to press start and then I'll hopefully see it or whatever.
I'll get rid of the music.
Okay, I've
so if
seen
you get yours
there.
If you get yours, actually, I'm going to pull it out.
Said he had to go. So you disappeared, Mr. Suitor. Uh-oh. Mr. Suitor got bumped. Don't know where he went. I can't see anything. There he comes. Mr. Suitor's coming back.
Don't worry. It's okay.
It's
a battle going on.
Mr. Suitor, just so you know.
What's that?
I've got 4 now on my side. So.
Dominic Gomez, you're not a little late. You missed the whole thing.
I don't know what I did here.
We'll have him play his homework. That's fine. I mean, it doesn't matter. We just needed you. We played quizzes today because we needed students to log in so we could see their. Huh?
Mr. Suitor, you're muted. I hear you yelling from the other room, but I cannot hear you at all, which means I'm just sitting here twiddling my thumbs while they're playing the game.
Do you hear me now? No?
Hand puppets? Right? And he left again. All right, ladies and gentlemen, I can't see any of his scores right now. Oh, he's back. He's in. He shoots. He scores. He's muted. He's unmuted.
You hear me? Hello? No.
Nope, can't hear you at all. No sound. Can you hear me? I could say whatever you want, whatever I want, and you can't, can't say anything back. Mrs. Smith is the greatest biology teacher of all time. If Mr. Suitor says nothing, he agrees that I am better than him.
Never in life. Did you hear that?
Mrs. Smith is always right. Don't say anything if you agree, Mr. Suitor.
Hello. Did you hear that?
Oh, we can hear both. Oh, you can hear him? I can't hear him at all. It's the strangest thing.
Wait, they can hear me? No. Well, then they heard my answers to your questions. I wonder.
That's so funny.
Well, you want to open the doors?
I can hear you again.
Did you turned your volume down, didn't you?
No.
You turned your volume
up, but like
you turned your volume down. It told me my mic wasn't working. This is what we do for them. Should we wait a little bit? Do you have kids playing now?
Yes.
You're a technology nightmare today.
I am a technology nightmare today.
Yeah, Luddite. There you go, children. Look up the word Luddite. Mrs. Smith is a Luddite. Word of the day.
Luddite. See, I've got 2 that clicked on the other link, but I can see where they're at. Like, I can see how many they got right. I can see their scores. So it's fine.
Mrs. Smith, why is the background of, look at this. Elijah's right. If I add to the screen and we hit the music, why is it a Christmas background?
Why is it the Nutcracker? I have no idea.
It's still Christmas.
I know nothing. Is this a hard one? They're at like 62% accuracy.
I'm at 72% accuracy. Ladies and gentlemen, that means you're more accurate than her students, which is good because
it's not fair. Mine are in separate things right now.
How many players do you have total?
6, I think.
I have 27.
What?
Minus 17.
So 10.
Yeah. My cat won't leave my computer alone. That's a problem. Wait, where did my I'm missing some people that were in the chat in the game though. The Moth King is not playing the game.
Right. I'm missing Nick, but he said he had to go to another meeting. So I don't know, at 11 o'clock, was there another live, you know what I mean? Was there another class thing? And I'm just seeing Maddie's comment from a while ago. She asked about papers. Yes, Maddie, you may turn your papers in on Monday. That's fine. But like Anthony popped in and I haven't seen him since he said hello and then he left for me. So we've had a few that like popped in and popped out. So what did we decide? For every correct answer, we're giving bonus points? Is that what's happening?
Yeah, we set a minimum of a half point for each correct answer.
Half point?
Mm-hmm. So if they got all 20 right, they would get 10 points. We think we're going to do that on Monday. We'll let you know on Monday what you got and put the bonus in. That way we can brag about it and like, you know.
Okay, so if you got 17 right, I would be giving 8.5 bonus points?
Yeah.
You're going to make me put in half a bonus point.
Why not?
Okay.
You can round up if you'd like. I might round up, but I'm nicer than you. Listen, when you thought my mic was muted, you were really going after me. All right, guys, that is really it. We're just kind of hanging out right now. But if you played the game, you will get some bonus points given to you. Remind us on Monday, but I'll try to remember on Monday during class to look and put bonus points in for anybody that played the game. We certainly appreciate those of you that showed up. That's awesome. Hopefully going over that worksheet will be helpful. Because really, you should have been done with bioenergetics yesterday, right?
Word.
Yeah.
Should have been. Should be ready for homeostasis, which I know there's some of my students that are in here that are there. So.
Yeah, some of mine too, but some of them aren't. So go ahead, finish the game. And I think with that, it is 11 o'clock. It's a little longer than we wanted it to be. So with that, I think we'll say goodbye to you lovely people. We'll see you on Monday unless it snows a lot. More than likely, we will call for a lot of snow and then nothing will happen and we'll all wake up disappointed after waiting up all night to see if it started to snow.
But don't worry, if we are on a FID day, Mr. Suter and I will appear from our houses on a live stream for you all to join in.
10:30 live stream on FID days. So we'll see you then. Anything else?
Turn in your work. There's some of you on here that like are saying this is easy. I've got this. And I haven't seen assignments from you. So do that, please.
All right. Peace out, people.